So welcome back to the class on MMM. Today I just wanted to explain you about the load cell accuracy level, how it is important and in what way it is being utilized across the world. And truly speaking, there are no like load cell manufacturers right from design to packaging in India. So these are done mainly in European countries and in USA. So people are trying to make some load cells of Indian make also, but it is not currently into the market. They are still in trial version. So these load cells are being procured at very high cost because the packaging and the material selection plays a vital role, and also the level of accuracy you need in the load cell and what is the load bearing capacity to which it has been designed. So everything will play a vital role. So related to that, I just wanted to share you some article about it. Just give me 2 seconds. So hope this PDF file is visible to you all. Hello.
Yes, ma'am.
Yeah. So this is one of the publication done by in this one what we call in Science Direct publication it is. So it was based on load cell accuracy, which was being done in 2000, and it is an payable version. Since I have access, I just download it. So you will be having a clear visuality between how you will evaluate the load cell based on accuracy and how it is being used, in which type of conditions you can use which categories of load cell based accurate one. So usually the abstract will speak about the entire paper. I told you in the last class also. And then comes the introduction. So the introduction tells you in which countries across the world they have manufactured already. So one is in United States, the other one is the European countries. Okay, so then we will discuss with respect to the accuracy class level and all other thing. So first you should know what do you mean by load cell accuracy first of all. So you know there are a large amount of grading in ranking the available load cells which are in the market actually. So it could be strain gauge load cells, it could be piezoelectric load cells, yeah, whatever type of load cells which are being manufactured. It is being ranked based on the material, based on the accuracy, and based on how persistent value it can provide for a longer period of time and how reliable the given load cell is. Okay, so load cells are ranked according to their overall performance. So what all I told you, so all these parameters will come under the category of overall performance. So based on the overall performance, the ranking can be classified based on its accuracy levels, and also based on the accuracy levels or the accuracy classes it could be graded. So a specific accuracy grade specifies an error envelope for certain parameters. So one of the load cell can provide you an accuracy of 100%. That shows that it is bound to 0% of error. So some can provide you an accuracy level of around 95%. So it is bound to provide an error for remaining 5%. So in this way, it will show you how accurate it is and what is the deviation, what it has been showing in terms of error. So based on these quality of the accuracy level, you can grade the given load cell. So this could be classified based on the parameters what we usually measure, such as how it is varying linearly, what is the hysteresis nature of the load cell, what is the temperature effects. Some of the load cell may not get disturbed by the external temperature. Some might easily get disturbed from the external temperature variations. So all these parameters together put together will help you in defining the accuracy grade for the given load cell. So as a result, in practice actually certain system of accuracy parameters are considered based on the type of application it's been used. So it could be a physical load interaction to the transducer or evaluating the disturbance factors. So what could be the disturbance factors while measuring? It could be some barriers or it could be some protection devices. All the device what you It could be a transducer, it could be a strain gauge, it could be a load cell or any measuring device. In order to see that it is not affected by the external environment, you should always think about a good packaging quality for the given device, because the material what we use will be sometimes corrosive, will be so sensitive to the external environment. So the packaging material what you use in order to keep the device safe for a longer run also plays an vital role. So that's what being told here. The disturbing factors are nothing but the barriers which come across while measuring, and that could be overcome by using proper protection device. So these protection device is nothing but the packaging level. So all the electronic device, electrical device, mechanochemical and electrical combined devices will be usually done within proper packaging. Without packaging, you cannot sell any product because they cannot withstand the external environment for a longer term, and it cannot achieve the reliability factor also. So protection devices, the packaging level will play an very much vital role. So that also you should consider. So this is the just outer skeleton about the need of identifying a load cell accuracy. But the next paragraph tells you why this paper, sorry, what is the factor on which the paper is focusing exactly. So this technical paper will cover the load cell accuracy grades as per OIML and NTEP standards. You will come to know what are these standards. So they are deriving the grades for load cell based on some standards and also on their compatibility when it has been used in legal for trade weighing instruments. So you will be using these load cells for high weight, low, medium also. So it depending upon the grade of weighing instruments you are using, so that also could be classified. And it will also cover the key terminology and metallurgical terms which are used in load cell and in the manufacturing people as per the scale. So this is the thing which will be considered in this paper. Also in this article, it will focus on the conditions of the load cell which are being used either to compromise or enhance the actual scale performance. Suppose if you have a load scale, it is performing well, but there are some deviations or the errors where you have to make the compromise part, telling that okay, this instrument has some percentage of error, so we have to consider this. So that is the compromise level which takes place. So without compromising, so you can try to enhance the actual scale performance of these load cell. So based on these aspects, the paper will be speaking about. So this is the overview what the paper exactly wants to tell you. So after knowing about the abstract part, we need to come about for introduction. So what's been done in the load cell until now? So I told that the two main giant manufacturers for the load cell are two countries. One is the United States and other one is the European countries. So here in United States, they are using National Institute of Standards and Technology as the standards in order to grade the load cells accuracy grade. So they are having their own handbook of grade 44, which is related to this NIST, and as per the protocol of this book, they are grading the accuracy level. Okay, so accordingly, the evaluation of critical metrology equipment and components in this standard includes about the load cell, how it is formalized, okay, by the National Type Evaluation Program. So there is an NTEP program. So this will be the team of the people who will evaluate the load cells which are manufactured, and they compare with the NIST standards, and they do provide the grading for the load cells which are being manufactured as per the accuracy level, as per the parameters what we explained over here, and based on the materials being selected. So they will sanction the grade for each type of the load cell. So in that NTEP class 3, so this is the team I told who will evaluate. So under that you have the section. So NTEP class 3 will cover most commercial weighing applications for the system for the range between 500 to 10,000 scale division. So you have different versions depending upon what is the weight you want to weigh about. So it can measure from least 500 counts to 10,000 scale division for class 3. So if it is class 3L, so it will help in ranging for measurement in between 2000 to 10,000 divisions. So you have different classes based on the type of weights the instrument is capable of weighing it. And also it is being told that so when it is being used and the weights are measured and you have the difference between the actual and the measured value, so the error comes into picture. So depending upon how accurate is, you can identify what is the percentage of error also. So the load cell error tolerance is also being assigned as zero point 0.7 times the scale division. Okay, so this is for single set. If you are using it for multiple set, it is 1 times the scale of division which has been graded in the load cell for the weight measurement. So you have to first check whether it is for single set or multiple set. So it depends upon the scale of weight what you want to measure and what is the range of weight you need to measure. So all these are associated related to the load cells which are being manufactured in United States and which is the standard they are using and which is the team who is evaluating and how the classes are graded based on the weight measuring scale divisions and what about the errors which has been set for single as well as the multiple set load cell. So this is about one part. So the next is related to European countries. So here what's happening in Europe, the guidelines for legal for trade weighing systems are being treated differently. Obviously, it will be different in different countries. It cannot be the same in all the countries across the world. So in order to harmonize and standardize an international basis, a convention was held in Paris in October 12th in the year 1955. And here many countries were participated and they have just formalized one of the standard because here what they are saying is the official language was French. The name of the organization is organization. Okay, just leave about the organization, not a problem. So here they have the standard what they come across after discussion with various countries across the world is OIML. Okay, so this is a standard what they are referring into. So OIML recommendation and documents are related to specific measuring instrument and the technologies bounded to that specific instrument. So this model regulations generally helped in establishing many metallurgical characteristics which are required for many measuring instruments. So it was some kind of generalized type of standardizing structure, so which helped in comparing many measuring instruments and it also helped in characterizing the metallurgical characteristics to map with that of the standard one, and I hope this was more comfortable and feasible than that of NIST. So here, since the meeting was conducted across the countries, in OINML they had members from each states or the countries. So in order to, they can put forward their recommendations, they can provide this thoughts, insight, and they can also help in having a proper finalized version of discussion with the other team members also. So this helped in making a generalized standard structure than focusing on specific related to a specific country. So what did this standard relay about the classes? So here OINML generated a class 3. So this covered commercial weighing applications similar to United States class 3 versions between 500 to 10,000 scale divisions. So this was the class division was almost same to NTEP class 3. So the OIML does not recognize any difference between the single and the multiple cell applications. So here, in case of United States NIST standards, they had a bifurcation for the error tolerance for single and the multiple set applications. But whereas in case of European standards of OI and ML, there were no bifurcation between the single and the multiple cell applications. That was the main difference. But what it did is, but it accepted and utilized the concept in the apportionment of errors. So the errors which come across systematically, right, so that was being considered, so they come into the category of OIMLR76. And one more they considered, load cells are tested and certified according to OIMLR60. So before using these load cells are tested. Okay, so how well it is performing, how accurate it is, whether it is calibrated or not. So all these things were being tested before it is in use. So this was as per the standard of OIML R60, and as a result, whether it is a single or a multiple cell, there will be no need to classify the error differently, because they are calibrating, they are checking initially, and finally they'll come to know like whether there'll be error or not. If error, how much they have to detect from the obtained result. So they'll be coming into an exact clear picture what is the error bar, which in which the load cell what they are using stands into, and what is its accuracy level. So this was about the standards where the European countries across the world while used, and this was specific only for United States. So further, reverse transducer manufacturers products meeting was held again. So that was for load cell, and this was for transducer manufacturer products who met NTEP, OIML, and with the in-house specifications. So they had the specifications in hand when they met the NTEP. So depending upon the standard and performance of particular load cell, an accuracy grade was assigned to the product. So how did they assign the grade? So they assigned the grade for that particular product depending upon the standard what they have referred for comparison, and depending upon the performance of that particular load cell type. You know that you have a huge classification of load cell based on material, based on the type, what you are manufacturing, everything. So based on the performance to the class of the load cells and in which way it has been compared with the standard materials. So comparing to those categories, the grade, accuracy grade was assigned. So the alpha designate refers to the specific accuracy class, while the numeric part refers to the number of divisions. So here you can see A, Z. So A suffix Z. So this is one of the accuracy grade given. So it tells you here clearly the alpha designate refers to the specific accuracy class, to which class it lies, and the numeric part which will be assigned. So you can see the numeric part here, 3 and 1. So this numeric part refers to number of divisions you have. Okay, so A suffix Z, so this is the product meet for NTEP requirements for class 3rd applications. Similarly, this was for class 3rd L application. Similarly, C suffix D was the grade for class 3rd and class 4 applications. And lastly, D1 slash D3. So these are arbitrary for in-house classifications, and it is not used in out trading part. So it is non-trading application which is being used for in-house, where it is not traded outside across the country, across the state, yeah, across the world also. So the Z which is being used here, A suffix Z, I told na. So it represents the number of divisions. So it could be into 1000, any number. So it will be specific. We are just explaining here the protocol or the terminologies how it will be used. So this Z stands for the scale. I told you, right? So the number of divisions. So this division can be multiple of 100 anything into 1000. Likewise, I've told you a suffix z. So here instead of z we can replace it by a3. So a suffix 3. It represents the number of divisions in that particular class. Similarly, instead of bz you can write b10 or b15 depending upon the number of divisions which has been classified with respect to the accuracy level. Similarly, C6. So likewise, the numbers could be shooted up. So this is a basic terminology what the European people followed as per the standard of OIML. Later, they had accuracy class defined. How they have defined this? So it is a class of load cells which are subjected to the same conditions of accuracy. So you will bifurcate the class based on the level of accuracy. So some load cells could be manufactured with high costly materials so neatly, systematically using all complex part of synthesis process and have done a very good packaging level. So these class of load cell might be having 100% or 99.99% of accuracy. So all the load cell who is shooting up with the very high level of accuracy will be classified into an specific section. So that will be classified as a specific class. Similarly, there could be other load cells whose accuracy is little bit lesser than that of 100% or 99.9. Suppose they might be lying between 90 to 99.99. So those will be classified into the second class. Similarly, the others might be showing an accuracy of 85 to 90%. So that could be shooted into a different class, right? And the accuracy also affects based on the parameters what I told you here, right? How it is characterizing, how it is varying linearly, what are its temperature effect, what are its hysteresis effect. So all those things are indirectly affecting the accuracy level of the load cell which has to be classified. So based on this, the class of accuracy will be classified. Once the accuracy class is classified, then only it will be helpful for you to grade in the given load cell. Okay, so this terminology you should be aware of. So next is load cell verification interval. So what is this? The load cell interval is always expressed in unit of mass, which is used in the test of the load cell for accuracy classification. So in order to classify the accuracy, you should be having some range of intervals for the load cell data which has been obtained. So that is usually expressed in terms of mass, because you will apply the load and you will check what is the actual and the measured load you are getting. So basically the unit of it will be in terms of mass. So you will just bifurcate into different interval range so that you can classify the measured and the actual weights of different slotted weights what you compare using an load cell. And next term what you have to understand is number of verification intervals. So how many intervals should be there in measuring using a load cell in a single stretch. So number of verification intervals used in the test of the load cell for accuracy classification. So you have to justify what is the number of intervals you are providing, how frequently the intervals you are changing. So this will go on with trial basis only until and unless you optimize the verification interval and the number of verification intervals. So once you yield up with a fixed numerical data, so that goes on and on with a similar thing for n number of measurements. Initially you have to do a trial version until you get an optimized way of bifurcating this verification intervals and number of verification intervals, which helps in classifying the given accuracy of an load cell. And one more parameter what you have to understand is non-linearity, which comes into picture while measuring the load cell. So usually what happens is You get deviations when you use an load cell. It depends upon how well it is calibrated also. Without calibration, you cannot use a load cell because it won't yield you with a proper reading. So the deviation of the increasing load cell calibration curve from either of these option will provide you if it is non-linear or not. So what is the first constraint is a straight line which passes through minimum load output and the load cell output at 75% of measuring range. Okay. So what do you understand from this? If it is varying linearly, the actual and the measured without much error, so that is a linear version. If it has to be non-linear, what is one of the criteria? So a straight line which is passing with respect to the measurement of the load should have the deviations. How? Minimum load output. So for applying for the minimum load, it should provide a load cell output of 75% of measuring range. So then you will come across some variation. It is not varying linearly. It is coming into a non-linear aspect. So this is one of the criteria. The second one is a straight line connecting the zero load and the rated load output values keeps on varying. So if the when how was the condition of the graph when it was in zero load, and how the graph is increasing when you add the load. If it is increasing abruptly, means for small values if it is showing a larger deviation, right? And again for increased load, again it is showing smaller deviation, means your it is not varying linearly, it is changing within a non-linear way, right? So then it shows this is the nature of a non-linear variation for the deviation of the errors. So this is the second option. The third is the best straight line fitted to output values by the least square method through zero load output. Sometimes we fit the curve also with respect to the variation you're getting from the measure to the actual by linear regression method and all. When we use the linear regression methods, we usually fit the curve with respect to the theoretical nature of the curve. So when you try to fit the obtained graph with that of the theoretical concept of the curve, if it is not mapping with the zero load output graph, then you can tell that it is not linear version, it is a non-linear type of variation what you are getting when the load is been increased in the given load cell. So all these criterias will show that how it is varying non-linearly. So these are the three parameters within which it has to fit into if you have to classify the reading under non-linearity. And last one is all measurements at a stable ambient temperature should provide a consistent range. So between 20 degrees Celsius, right? So you should at the room temperature usually between 20 degrees Celsius to 34, yeah, 40 are the upper limit. So you should show an proper measurement. You should not be any variation as such. Suppose at room temperature 30 it shows some value, and again at 34 degrees Celsius it is showing some other value, then it shows that it is not in right one. It is fluctuating and it is very sensitive to even a small change in the environment. That should not happen. That will not happen also because the packaging plays here a vital role. So packaging is nothing but the packing protection device. How do you develop for the load cell which will be kept inside? Okay, so this is about the non-linearity aspect. And if the load cell reading varies very abruptly for small change of temperature, then also you call this as a non-linearity. So these are the four concepts in which you can classify the obtained values will fall into non-linearity character. So then other nature of the load cell is about the hysteresis. So we spoke about what do you mean by hysteresis, what are the type of hysteresis loop we come into picture in our previous modules when we studied about. So here you can just see the difference between the load cell output reading for the same applied load is being shown. So you will be having different load cell output readings depending upon what loads or the slotted weights or the load what you are applying in the instrument, right? So one reading obtained by increasing the load from minimum to the from minimum load, and other is from decreasing the load from maximum. So even we have shown you how to perform a load cell experiment, one from maximum weight to that of the least, another from decreasing to that of the increased version. So based on these trend, you are plotting here the load versus the output reading what you are getting, and we are tracing to understand the nature of the hysteresis here. So here you can see one is for non-linearity. So this is the hysteresis loop what we are getting from here, and it is again coming back. So this is for non-linearity, and this is for second one is for hysteresis. So this part it goes like this with the increasing in load, and when the load get decreased and again it comes back. So these are the hysteresis loops which comes into picture with respect to non-linearity version and with respect to the regular hysteresis. Okay, so when you increase the load, the variation you get. When the load is removed, it will be having some capability to withstand the applied load. So what is the reaction which is coming into the body due to the retention of the force within it, and due to the formation of the deformation whatever it is will be traced out in the backward direction. So this will provide you the entire loop. How does it look like for an load cell? And apart from that, you should know one more terminology, what do you mean by creep. So you know what you mean by creep, you have studied your subject material science. When the load has been subjected to load, right, it could deform, crack can come into picture, and the crack can penetrate to particular range. So all these you know, right? So in that aspect you have to relate now the creep, yeah, penetration into the surface when the load has been applied. So what's happening here exactly related to our creep? So the change in load cell output occurring with time while under the constant load and with all environmental conditions and other variable remaining constant. So what did you understand? So here it is being told the change what you are obtaining in the load cell output will occur and will vary with respect to time when you are subjecting a load for a consistent period of time. So it means you are applying a constant load for a particular dwell time. So when you apply a constant load for particular dwell time, what all the changes which happen in the body on which the load is being applied. So it could deform, right? It could some fracture could happen, so it could penetrate, a creep can come into picture. So what are the reactions that happens when you apply a consistent or the constant load for a particular period of time? So that will be considered. The load can be applied for a short period of time. Apply the load for a second, yeah, for a minute, and remove it. Then the result what you're getting is different. You apply the load, a constant load, don't increase it, but keep it constant for a long period of time. The result what you get is different. And the other thing is you keep on increasing the load what you want to apply with respect to the time, then also the result what you get will be different. So it depends upon how you are applying the load, whether it is consistent, whether it is increasing, or whether it is decreasing. So depending on that, the nature of the creep also could be analyzed. What does the paper tells us exactly? So based on this, the OIML standard. So OIML is with respect to which standard? So it is with respect to our European standard, right? So based on OIML recommendation under the grade 76, it requires a 30-minute test, and then only it can specify an error limit for this time period. I told you na, the dwell time is here nothing but the 30 minutes. So you apply the load and wait for 30 minutes. In our experiment load cell, what we did, we just added a weight 1 kg, 2 kg, 3 kg until 10 kg, and we just took the readings. We didn't see what happens if you keep the same weight for a particular dwell time. Then only you can know the error deviation, the limit of the error, which is the minimum error it can show and which is the maximum error it can show, and you can find out the deviation, the error bar for that particular load what you are applying. So that helps in defining how accurate the load cell what we are using exactly is too. So if you need to do it, always we need to set the load applied and wait until for a particular dwell time. So that could be for 30 minutes or it can also be between 20 to 30 minutes. Means the range of 10 minutes is the minimum what we have to consider and the maximum is for 30 minutes. So this is how it will be helpful to identify the errors. So based on the errors, you can classify how accurate the instrument is. So this is the very best way in order to perform to check the accuracy class of the given load cell. So as per the European standards. But this was about OIML. If we speak about NTEP, which was our American standards, it tells that NTEP requires a 1 hour test